Today, we're going to build a mesmerizing particle field animation. It's a fantastic way to understand custom painting and animation in Flutter, and we're going to break it down piece by piece. First, create a new Flutter project. Our main.dart file simply sets up our material app and points its home property to our particle field widget, which is where all the animation magic happens. Now, let's switch our focus to the particle field.dart file. This is where the entire particle animation logic is housed. We begin with the particle class. Think of this as the blueprint for a single, tiny, animated dot in our field. Each particle object holds several key pieces of information. Its position on the screen, represented by an offset. Its velocity, also an offset, which determines both the direction and speed of its movement. Its size, a double that controls how big the circle appears. And its color. We also have a random object within each particle, which helps us give each one unique starting properties. When a particle is created, its constructor immediately calls the reset method. This method is crucial. It randomly sets the particle's initial position within an 800 by 800 pixel area. It also gives the particle a random velocity, meaning some will move left, some right, some up, some down, and at varying speeds. The size is also randomized, making some particles bigger than others. Finally, a random color is picked from colors.accents, with a slight transparency applied. This reset method is also what we'll use to bring a particle back into view once it leaves the screen. The update method is called on every single frame of our animation. Inside it, the particle's position is updated by adding its velocity. This is what makes the particle move. Immediately after that, we check if the particle has moved outside our predefined 800 by 800 boundary. If it has, we simply call reset, again causing the particle to instantly reappear at a new random position, creating that continuous flowing effect. Next up, we have the Particle Painter class, which extends Flutter's CustomPainter. This class is responsible for the actual drawing of our particles onto the canvas. It takes a list of particle objects in its constructor. These are all the particles it needs to draw. The core of CustomPainter is the paint method. Flutter calls this method whenever it needs to redraw our custom content. Inside Paint, we first create a paint object, which is like our digital paintbrush. Then we loop through every P particle in our particles list. For each particle, we set the paint.color to the particle's specific color, and then we use canvas.drawCircle to draw a filled circle. We pass the particle's position as the center of the circle, its size as the radius, and our configured paint object. This process draws every single particle as a distinct circle on the screen. You'll also see the shouldRepaint method, which for our animation, simply returns true. This tells Flutter, yes, my drawing logic depends on changes that happen constantly, so please repaint me every time the animation frame updates. For a dynamic animation like this, returning true is essential to ensure the particles are always moving. Finally, we arrive at the main particle field widget. This is a stateful widget, which is necessary because our particles are constantly updating their positions, and the widget needs to rebuild to reflect these changes. Inside its associated state class, particle field state, we see a few important members. We have an AnimationController named Controller, which will drive our animation, and a list of particles. We also define particle count as 150, meaning we'll have 150 independent particles in our animation. Notice the with single ticker provider state mixin on our state class. This mixin provides the necessary ticker that our AnimationController needs to know when a new frame is ready, allowing it to synchronize with Flutter's rendering pipeline. In the initState method, which is called once when the widget is first created, we perform our initial setup. We populate our particles list by generating particle count, 150 new particle objects. Then we initialize our controller. We set its vsync to this, thanks to the mixin, and give it a duration of 20 seconds. The repeat part is vital. It makes the animation loop endlessly, ensuring our particle field never stops. The dispose method is where we clean up. When the particle field widget is removed from the widget tree, we call controller.dispose to release the animation resources and prevent memory leaks. And then, in the build method, we bring everything together. We wrap our custom drawing in an AnimatedBuilder. This widget is perfect for animations because it only rebuilds the part of the widget tree that depends on the animation, making it efficient. For every tick of our controller, the builder function is called. Inside this builder, The first thing we do is iterate through our particles list and call p.update on each one. This ensures that all particles calculate their new positions for the current frame before anything is drawn. After updating their positions, we then use our Custom Paint widget, passing it our particle painter and providing the full screen size via Media Query. So when you run this application, you'll be greeted with a dynamic and subtle background animation. You'll see numerous small, colorful particles, each moving independently across the screen. As individual particles drift off the edges, they'll seamlessly reappear from a new random location, giving the impression of an endless, gentle flow. It creates an engaging visual effect, perfect for a background element or an artistic display. And there you have it. I hope this explanation has clarified how all the pieces work together, from the individual particles to the custom painting and animation controller. Feel free to experiment with the particle count, particle size, and velocity to create your own unique effects.